With the Layup Builder, you could also perform simple mechanical analysis. We made the Layup Builder previously for the simple plate, and we made 2 paths. We go now again on the Build Layup 3D, and we check that how can we analyze the layup. So this is the layup, as you previously saw that in another video. And what we are going to do is perform the simple deformation analysis. Before doing that, let's have a look what are the buttons here. At the right side, you will see the hide and show button, which you select and unselect and hide and show each object. And also the changing the lighting conditions. So for performing this analysis, you need first to follow this material, these icons here. Or you could also go through the menu button, which is the physical constant, and go from left to right. So starting from here, in the parameters, we select this. So here we assign the material properties for anisotropic material part, for the elasticity modulus along the 3 directions. You will see the values and the portion ratio and this G12, and which is a shear modulus. You could assign the new material. You could set the name here. I set it at the material 2. I set it with this button. I changed the value a little bit to a different values. So we're 3, the one. And you could assign the material and then save the material if you want to use it later. You could also change the setting regarding the penalty function where this model works. This is the value between the contact between the layers. So a higher value means that 2 layers are connected to each other very well. And a lower value means that it's going to be having a sliding through them. So this is basically based on the formulation of the penalty in the finite element. This is a time discretizations that the analysis will be performed in how many steps. And with this icon, you could select that if the stiffness matrix will be recalculated by changing some boundary condition or not. Please note that the stiffness matrix will be calculated 1 time, and then there would be steps, like here 10 steps, based on that stiffness matrix. So a stiffness matrix will not be recalculated in each steps, 1-time calculations. You could select or unselect this one. So every time you change the boundary conditions, the stiffness matrix either recalculate or using the previous calculated ones. And with this icon, you could also indicate that if the base object, which is here, base rectangular shape, will be used in the analysis or not. So when you assign this, you could close the window and go to the next one, which is assigning the material. You could select the material that you just built. So material 1, I set it to material 2 for the layers, for tape 1 and tape 2. And when you assign the material for the tooling 1 and the other objects, you could close the window. Then the next step would be the assigning the boundary conditions. For the fixed boundary condition, select on this button and select the object that you would like to assign. Object 1 is a tooling 1, and with the order I would be tape 1 and tape 2. I set it at this one, object 1. I select a point node to assign this. As you see on the below picture, you have 3 options using the single point boundary conditions, or tangent plane, or closest points. With the closest points, it assign the closest, for example, 50 nodes near to these points that you're selected. And with the tangent angle, you will select the nodes which have a certain criteria regarding the angle with that. So here we have 18.6. You can change it to up to like a 90. So because this face and this face has a 90-degree angle between each other. So I set it as it is. I click on preview, or preview is just showing that which nodes will be previewed. And with this one, you select the faces. So each element has the 6 faces. So you select between them each faces to be selected. I select this one, which is black now, and click on OK. You will see that these nodes are highlighted as the selected ones. So again, now we add this one, this boundary condition, we face number 4 and this object, and click on this checkbox. Then the name of the boundary condition would appear, and the movement. So we try to fix it, so we keep it as it is, 0. You will see that it would be assigned. And now you could assign also the boundary conditions, like a force boundary condition or the movement boundary condition to the other side. So for the movement, for the force boundary condition, you could assign the external force. You click on this, select the object, which is 1, and bring the point to here. And again, we try to choose that face. Click on add. We select that face, which is now face number 1, as you see it on this picture, this view, and click on OK. You set the force. We'll try to add the force along this x-axis. We add the force like 1000 for Newton, and we click on OK. Now it's done, and the next step is to perform the solving of the finite element. So click on this solver, or you could also select from here, solving, mechanical analyzer and solving, or you just click on here, solving FEM. And it takes a couple of seconds until this will be performed. So now it's done. And we could now perform the formation analysis. You will see here with this arrow at the left and right, you could see the simulation of the deformation. Now the deformation is very small, like at this range. If you like to change the boundary condition, you could easily go to manage boundary condition and force. Here you see that this is the boundary condition fixed, which is here, and this is assigned nodes, and this is the set indices, and this is the imposed object. Now we try to change the force. We change it a little bit, add it like 10 times more to see the effect. And now when you're done, you could update it. You could also save the boundary conditions or load the boundary condition that you had before. Now I update the boundary conditions and close it again, and I perform the analysis again. Now the formation order would be a little bit higher. Now I would like to make it more visible, so I change the force again. I come to the external force, and you will see the highlighted nodes of the force here, where it shows as the blue, light blue. I made it one order bigger, and I close it, and again I run the simulations. So you will see now the order is a little bit now bigger. What you see here is that the deformations, this amount, that you see the deformation here. If you would like to see the stress and strain, you could click on the result observer and stress and strain. Click on it and then ask for new calculation and click on OK. So the two side bar will be shown here. For a displacement, you will see the displacement along the x directions, x-axis, y-axis, and z-axis. You see the strain value. See the strain value here for the along all of the axes. Shear the strain and the stresses. For the stresses, we also have a standard stresses along the directions, principal stresses, which is P11, and P22, which is this first, second, and third directions. You will see the value for each tapes also here. And you also see the principal axis, that if you are interested to see the direction of the stresses and the strain along the principal directions here. For each object, you could hide and show the object here and see exactly what objects are shown. You see all of the load directions along the objects here. And the last principle is stresses directions, which is along that directions. I have shown also the whole object again here, and go to the stresses and select one of the stresses, and you will see you could see the animation of the developing stresses and displacements finally. So you could also do the animations. So if you do the animations, the animation will be saved. So I choose a appropriate view to perform the animations and see the animations here. So it asks about the animation name, simple plate, and quality and the frame rate. I change it as default. So you see the animation will be generated, and you will find the animation file in the directory. If you go to the directory, you could find it. Here, it was saved in the directory of the installations. And you will see there these animations of the formations here.